Rational functions make crazy graphs like this, but at the end of the day, finding the x-intercept and the y-intercept are the same as it is for any function. Y-intercepts are spots on the y-axis. What do we know about the y-axis? The x-coordinate there is 0, so to find the y-intercepts, we just plug in 0 for x. For this function, if I plug in 0 for x, I get (1.5). What is my y-intercept? 0, 1.5. For this function, if I plug in 0 for x, I get (-5/8). What is my y-intercept? 0, (-5/8). For this function, if I plug in 0 for x, what do I get? Oh, 5 divided by 0, that's undefined, so I can't plug in 0 for x, so there can't be a y-intercept. Look at this graph, no y-intercept. X-intercepts, similar deal. What do we know about x-intercepts? They're on the x-axis. What's true on the x-axis? Your y-coordinate is 0. To find x-intercepts, I set y equal to 0, and then I solve. Remember that when we solve, we have to think about what our excluded values are. For this equation, x cannot be 4, and x cannot be -2, because then it'd be divided by 0. To solve the equation, I just need to figure out what makes the numerator equal to 0. The only way that I'm going to divide two things and get 0 is if the numerator is 0. The numerator is 0 when x equals 4 or x equals -3. Oh wait, x can't be 4. My only x-intercept is going to be -3. To find x-intercepts, I plug in a 0 for y, solve for x. X can't be -2, and x can't be this imaginary thing, which who cares about the imaginaries? X can't be -2. The solutions are going to be where the numerator is 0, the numerator is 0 at -5, and at 1, neither is an excluded value. My x-intercepts are 1 and -5. Plug in a 0 for y. Excluded values. What makes the numerator 0? The only x-intercept is x equals -2.5.